The 3D picture block spherical camera mode is used to visualize the robot. The code is inside a while loop providing constant update on the joint positions. A case structure is used to switch between manual and automated operation. LabView's robotics module is used to build a robot arm. Forward kinematics block is used to get the transform of a generic arm design. We get the translation vector of the homogeneous transform obtained earlier and index x, y and z separately in the array to be used and manipulated later on. The arm has 4 revolute joints. The first joint is responsible for moving at the y-axis. The second and third joint is responsible to manipulate the tool position on the x and z axis. The length between frames was chosen to fit the task of reaching the 3 shelves and the floor as well. For simplicity, the dynamic properties of the arm are not used in this example. Initial joint positions are given to successfully calculate the 4x4 transform matrix. After changing the coordinates of the end effector to the desired new coordinates, the inverse kinematics block is used to calculate the required joint positions to achieve the right tool position. Shift registers make it possible to use the changed positions as the initial positions in the next loop. As the coordinates for the automated robot arm will be given in an array, a for loop is used with auto-indexing turned on so the path planning function can go through them one by one. The trajectory is also given in an array of steps. This is the reason for the second for loop. The next step will be the manual control in the case structure. The original x, y and z coordinates can be increased or decreased by using buttons and numeric functions. The select function used is responsible for the control. When the button is pressed, the select block will use the modified value instead of the original value. To make sure to give achievable coordinates, comparators are used to stay between limits. When the new coordinates are above or below the limit values, the increment values are not used anymore. This way the robot joints will not lock up or bump into the wall. Preset coordinates are sent to the for loop as an array for the trajectory planning block. Preset values in order are home position, floor, first shelf offset, first shelf, second shelf offset, second shelf and so on. This way the robot will move to the floor level to pick up object, move to in front of the shelf before placing object and then back out and repeat with all 3 shelves. A pre-made sub-VI is used to create the 3D object that is the room with a table and 3 shelves. The 2 scene objects are imported to the same space in a way that the robot RM is positioned on the table. The camera needs to be set to spherical, the while loop needs a control element and the XYZ rotation needs to be disabled. After fixing a few missing connections and commenting the code for others to understand easier, the robot parameters can be tested in the environment to determine if it is fit for the task. This is a good way of planning a robot arm before time-consuming and expensive building procedure, as it points out errors in the early planning stage. The arm's base is fixed at a table representing a turtle, but first it is demonstrated how to control it manually, and after it will move automatically in a loop according to the preset coordinates in the world.